Introduction to multiplexers. A multiplexer, often abbreviated as MUX, is a digital device that selects one input signal from multiple inputs and forwards it to a single output line. It's a fundamental building block in digital circuits and systems, enabling efficient data management and communication. How a multiplexer works. A multiplexer operates based on selection lines or control signals. These lines determine which input should be routed to the output. For instance, in a 4-to-1 multiplexer, there are 4 input lines, but only one of these is selected at a time to be sent to the output. The selection is controlled by 2 selection lines, which can be configured in 4 different ways, corresponding to each input. Multiplexer structure. A typical multiplexer consists of input lines. These are the multiple data sources that need to be routed. Selection lines. These control which input line is selected. Output line. This is the single output where the selected input is sent. Logic gates. Internally, a multiplexer uses logic gates like AND, OR, and NOT gates to control the selection process. Types of multiplexers. Multiplexers come in various sizes depending on the number of inputs they can handle. 2-to-1 multiplexer. This has 2 inputs and 1 selection line. 4-to-1 multiplexer. This has 4 inputs and 2 selection lines. 8-to-1 multiplexer. This has 8 inputs and 3 selection lines. 16-to-1 multiplexer. This has 16 inputs and 4 selection lines. As the number of inputs increases, the number of selection lines required also increases, calculated as log 2n, where n is the number of inputs. Real-life use cases of multiplexers. Communication systems. In telecommunications, multiplexers are used to combine multiple signals like audio, video, or data streams onto a single transmission medium. This allows for the efficient use of bandwidth by sending multiple signals over a single line, which are then demultiplexed at the receiving end. Data routing in computers. Within a computer, multiplexers are used to route data from various sources, like registers, memory, or input devices, to a particular destination, such as the ALU, arithmetic logic unit, or another part of the system. Control systems. In automated control systems, multiplexers help in selecting different sensor inputs to be monitored or controlled by a single processor, enabling efficient data management and reducing the need for multiple processing units. Demultiplexer, the opposite of multiplexer. While a multiplexer selects one input out of many to send to a single output, a demultiplexer does the reverse. It takes a single input and channels it to one of the many output lines based on the control signals. This is crucial in scenarios where a signal needs to be distributed to different destinations. Advantages of using multiplexers. Efficiency. Multiplexers allow the sharing of a single line among multiple signals, making the system more efficient. Cost-effective. By reducing the number of lines required for communication, multiplexers help in lowering the overall cost of wiring and components. Simplified design. They simplify the design of complex systems by reducing the number of connections needed. Disadvantages of multiplexers. Delay. The selection process in a multiplexer might introduce slight delays, especially in high-speed circuits. Complexity in large systems. As the number of inputs increases, the complexity of the multiplexer also increases, which may require more logic gates and careful design. Conclusion. Multiplexers are crucial in modern digital systems, enabling the efficient management of data and signals. Whether in communication networks, computers, or control systems, multiplexers help streamline operations by reducing the number of lines needed for transmitting data. Understanding how multiplexers work and their application in real-world scenarios is essential for anyone involved in digital electronics or system design.